This conference will now be recorded.
Right, let's start today's session. In the last session, we were discuss about lambda expressions and where do we use exactly lambda functions. Means lambdas are generally instant usage. So we have seen already filter function, map function. In this context, we can use lambda because filter, map, reduce functions will expect other function as an argument. So in this context, we use lambda expressions. So here one is filter function, next one is map function, and next reduce function here, reduce. These functions will expect always other function as an argument. So that's where instead of calling other function always, we are going to use instantly lambda expressions. So lambdas are for instant usage. Lambdas are for reduce the length of the code. Lambdas are for improve readability of the program. And using lambdas mostly, we'll write single line expressions. So filter function is used to filter the values from given sequence. And map function means we can apply each and every element present in the sequence, apply some condition, and return new sequence of elements. So we have seen these two in the last session, filter as well as map. Now today we'll look into reduce function. Reduce function also will expect other function as an argument, but it reduces the values by collecting values from the list. It is used to reduce the values from the collection and return a single value. What is reduce function means? It is used to reduce the values of collection and return a single value. Return a single value, sir, actually here. Reduce function is used to reduce the values of collection and return a single value. So reduce means all the values will be reduced in the context of adding, subtracting, multiplication, any format you can do, any logic you can apply. But ultimately it will reduce the value. Only one single value is going to return. So this is reduce function purpose actually. It is used to reduce the values of collection and return a single value clearly. Okay, yes. So how we can use reduce function, we'll see now. But just observe here, the moment when I use here map function, it's coming in IntelliSense, no? So map function is always, it's available directly. There is no issue, and even it is coming in IntelliSense. Map function is there. You can able to capture there. And even filter function also, when I try to write filter function, now filter function also is coming in IntelliSense like this filter. Filter is coming and reduce is also coming. Sorry, map is also coming. But the moment when I try to write reduce function here, you can see reduce. Is this coming? No. Look at this. There is no reduce function is available here. So it says underline red squiggly. That means to use reduce function, we need some module that is called functool modules. Let's see other program so that you will get clarity. So add a new program test 32, just test 32 here. Now here I'm trying to write reduce function. Reduce function is not available right now. So it's recommend to use one more library that is called functool module. This function especially present on that module, functool modules. Now you can see when we place mouse pointer on reduce function, like import this, they are asking. Import this means what? Functools dot reduce. So reduce function is present in functools module only. So now you can see from functools import reduce. You know how to import like this, you can directly write it and use it here. Sometimes we can also use like from functools import star. Star means all functions which will come from functools module, or else sometimes we can import like this, import functools module And even when I import functools module, if I try to use reduce function, even reduce function is not appearing here. You can see this reduce function is not appearing here. Okay, so why? Because if you want to use this reduce function, functools we have to use. Now you can see functools dot reduce function you have to use, sir. Functools dot reduce. So module name dot function name, or else instead of writing every time module name dot function name, in simply we can suggest like from functools import star. So from functools module we are importing star, or we can say reduce, because star in the sense all the functions which are coming from functools module, that's what we use. What actually reduce function is required, because only one function I'm using in this current program. So it's a better to use reduce function only here. From functools import reduce. Okay, this is the case. Let's see this how we will work with reduce function. What is the purpose? We'll see this. So as I said that reduce function also always expect other function as an argument. So in that context, we can avoid that. We can use lambda expressions. Let's see this first. L1 is a my list one, and list one I'm taking here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any number of values you can take, not a matter. Just I'm taking list of values. Okay, list of values. This is list. I want to reduce this list of values by adding or subtracting or multiplication anyway. So for that, I'm creating one separate function here. So def f1 is a function name. F1 function is taking two input parameters x and y. While returning this x plus y, I'm taking. So that means for adding two numbers way, I'm trying to reduce the values. This function is responsible to do some logic. What logic I have written? Return x plus y. So every time L1 values 1, 2 will go first. X value 1, y value 2, x plus y 1 plus 2, 3 only. Next iteration x value 2, y value, x value 3, y value 2, 3 plus 2, 5. Next iteration x value 5, y value 3, 5 plus 3, 8 like that. Let's see this. Finally, result value I'm taking result because it's not a list, result only. Reduce function I'm using here, reduce function. General reduce function also is expect other function as an argument. You can see the intelligence, there is a clear syntax function comma sequence. What function is there for conditional checking? Like f1 function is there, comma in which sequence is there? L1 sequence. Now reduce f1 function comma L1 sequence here, L1 capital L1 sequence here. So result equals to reduce of f1 comma L1 only. Result equals to reduce of f1 comma L1. So this is reduce function, f1 comma L1 is available here. This is L1. So in this L1 list, this reduce function always will call f1 function for reducing the values of given sequence like L1. So after reducing it return a unique result value, it integer value it is. So now let's see this print result only finally. So this is for reducing the values purpose. This reduce function always depends on which function? F1 function. I have already written inside the F1 function some logic for reducing the values of the collection. Once I run this, now you can see we got this 55 is the value. How it reduce the values, you will see this. So this is lengthy actually, and more process need to be required. The reason is of all the values will go to here f1 function x and y, so x plus y. So each and every first iteration x value 1, y value 2, x plus y, that is 1 plus 2, 3, return 3. Next iteration x value 3, y value 3, 3 plus 3, 6 like that only. Okay. So let's see the debug, right click on it and debug test 2, test 32. Now you can see debugger window started here. Now, so once debugger window started, I'm hitting function key plus F8. Function key plus F8. So L1 list is collecting the all values, and we are performing reduce function. Reduce function will call F1 function for reducing one by one value from the list collection L1. Now we can see F1 function is calling by reduce function, and by sending the values to the reduce values to the F1 function, x value 1, y value 2 here. So finally what we are getting, x1, y2, 1 plus 2, 3 only here. Next, x value 3, y value 3. That means what actually, 3 plus 3, 6 only here. X value 6, y value 4. 6 plus 4, 10 only. X value 10, y value 5. 10 plus 5, 15. X value 15, y value 6. X value 21, y value 7. Like this. Let's keep on reducing the values. Finally, we will return one value. This is the result value. How the way you want to reduce, you can decide that. Not only by adding. Look at this. I'm changing my expression here. X into y. So each and every value can be multiplied with itself. 1 into 2, 2 into 3, like this only. It will also reduce after multiplication of all. Now you can see this is okay. It will reduce all the values and multiply with multiplication form. But it is not recommend, because this reduce function always call other function f1 every time it will call. To avoid this other function, what I'm just commenting here. So instant usage purpose, instead of calling f1 function, we recommend what's a lambda. So let's go for lambda expression for reducing the values. In what way you want, you can reduce that, no problem. So single line expression, instant usage purpose, no need to call every time f1 function. Instead of calling f1 function, in that place we are trying to do here lambda x comma y x plus y, you are doing. Then run this. Now we got this 55 value here. That's it. So result equals to reduce of lambda x comma y x plus y comma L1. So this is very clear. So result value we are getting here. So this is lambda expression where exactly we use. In Python programming, some functions will expect other functions as an argument, like filter function, map function, reduce function always expect other functions as an argument. Instead of using other functions, better to use lambda expressions for instant usage. We can easily fulfill the requirement with writing lambda expressions, and we will improve the readability of the program, will reduce the length of the code, and all these things clearly. So still we need to discuss few more topics related to functions before going to move our next topic, that is modules in Python. So still we need to talk about few more topics related to exclusively functions, that are function aliasing, recursion, mechanism, okay, nested function related. So first I'll talk about function aliasing. What is function aliasing here? Okay, function aliasing. Function aliasing means what? So function aliasing means it's just a process of giving other name to a function is called what? Function aliasing. Function aliasing is the process of what? Giving other name to a function is called function aliasing. Giving other name to a function is called function aliasing. We can say that. Why we use other name? Yeah. See, once we create a function with a name, generally we can call the function with that name only. If you delete that name, so there is no option to call the function again. So that at that time, if you delete the definition of the function, still there is a chance to call the function by using its alias name. Alias name means other name of the function. Okay. So this is function aliasing, but make sure that once we delete the function definition, alias name through we can access. Why it is possible? Because the original name, alias name, both identity is same. You know about identity, how to find. So id function is their built-in function. Through that id function we can find the identity of functions, identity number, memory address of the functions clearly. So how to do it? We will see this. So let's see this how we can go for function aliasing mechanism. It's a very simple concept and straightforward concept. There is no big deal. So let's see this test 33 I'm taking here, and now here I'm creating one function f1 function. The moment when I call f1 function, I can say that hello. So I'm calling the f1 function here. So f1 function I'm calling test 33. So now you can see f1 function hello is coming clearly here. Okay, this is hello. F1 function is available here. Okay, here. But for example, I'm trying to delete that f1 function definition. Del f1 is the name of the function deletion. After deletion of the function name f1, but still you are trying to access this f1 function calling, but it's not possible because the name error you will get because we delete this name f1. So this name error name f1 is not defined. Name f1 is not defined. Yes, it's not defined. You defined, but we deleted. After deletion, again we are calling the f1 function here. That's not correct. So still, though, if you delete that one of the name of the function like del space f1, still if you want to call the same function, then we can use function alias name. Function aliasing means for like this f2 equals to f1. So f1 I am assigning to f2 only. I am deleting f1 here. So we have to call with what actually f2 only. So we deleted one name and still we have other name to call the f1 function f2 through. So now we call the function with alias name f2. It's working fine. F1 will not work because we delete the definition of f1 only. F1 will not work. F2 will work now. You can see f2. F2 function. F2 function is working here. F1 function is not going to work. And let me show you. Let's comment this one. Why? Because I need to give the clarity. Both f1 and f2 identity is same or not, we have to check. The print id of f1, sir. Id is a built-in function which is used to get memory address of the variable. Print id of f2 here. Print id of f2. So id of f1, id of f2. Both identity is what actually same, sir. So both identity same. So look at the 6480, 6480 memory address number is same. Both identities same. That's what even one name is deleted like f1 name, still we have option to call f2 name through. Yes or no? So one name is deleted here f1, but still I am able to call the function with same like f2. F2 is the alias name, f1 is the original name. So this both are having same identity. That's what we can able to work with f2 also. This is function aliasing concept. Next, nested function is there. Nested function, I'll give you basics here, but in our upcoming session, we will go with nested functions in detail. So what is nested function generally? Sometimes we can declare a function inside another function is called nested function. You know how to create a function and how to call function directly, but we will see nested function, how to create and how to call it clearly. Okay. So let's see this, how to create, how to call a function clearly. So nested function within the function is called nested function. Sometimes we can declare a function inside another function is called nested function. We can say that. Okay. So let's see this, how to work with nested function, all these things. So I'm creating a function. Just a moment. Now you can see here test 34. Now here I'm taking f1 function. Print hello, I can say that. Inside this f1 function, I'm calling, just a moment, I'm calling this f1 function as 34.py. Let's run this. Now we got this hello. Perfect. So I'm creating one more function df f2 function here and print what I can say hi like this. So here I'm calling f2 function. So these two are actually what not nested function. because f1 function we are calling, f2 function we are calling separately here. Two are separate functions. Once I run this, now you can see hello, hi is available. So hello is one and hi is another thing. So f1 of hello, f2 of hi, like this f1, f2 functions are working fine. Okay, this is the case. So, but this is not a nested function. I want to make this function as nested, a function which is having another function inside. Now you can see this is nested function. This line indentation both are matching. So this portion under comes into f1 function body, but this is not the way to call f2 function. So this is not the way to call here. So how to call this one? You can see this here. I'm taking f2 function. I'm calling here. So let's run this one. So now you can see hello, hi is available here. Hello, hi. So this is the way to call f2 function, because now f2 function is fully depend on f1 function. That we have to mind it. So if I don't call f1 function, just observe here. I'm commenting this f1 function. Okay, let's run this. Now you can see this one is f1 function. I'm not calling. Only f2 function also not calling. F1 function, if I don't call, then this will not execute. If this will not execute, even control will not move forward to this block of code. So f2 is depending on f1 only. So let's call the f1, and f2 also will work fine internally. Hello, hi. If I don't call f2 function, then f1 function will work fine. Hello. So this is makes dependency. Even inside the f2, one more function I'm creating f3 into what I can say here, welcome. Then here f3 here I'm taking clearly. This is what actually, let's run this. So hello, hi, welcome is available. Hello, hi, welcome. So f2 function is depend on, sorry, f3 function is depend on f2. F2, f3 functions are depend on f1 only. If I don't call f1 function, no output will come because main function is missing. If I call f1 function, then complete output will come f2, f3, all these things. Suppose if I don't call f2 function and only f1 function, logic will come hello, welcome, hi is missing. So it is dependency. So this is called nested function. You just make it idea about this. We'll discuss in the context of generator, decorators. There obviously we have to use nested functions logic only. So this is nested inside the function. One or more functions we can include. We have to call like this only. And next, recursion mechanism is there. Recursion functions are there. Recursion is not a function name for your kind information. Recursion is the type of process actually. Recursion is one of the process. Recursion is one of the process actually. Let's see this how we can work with recursion, how it is possible. Recursion function means a function that calls itself every time is called recursion. Recursion function. Recursion function means a function that calls itself every time. A function that calls itself every time. Function that calls itself every time is called recursion. We can say that is called recursion. Function that calls itself every time is called what's are actually recursion mechanism. This is recursion mechanism. See, generally, what is the best example of recursion function means factorial of given number is a recursion function. Factorial of n. So let's see this formula n into factorial of n minus 1. This is recursion mechanism. Suppose here I'm taking n into, suppose if I want to find factorial of 3, for example, to find factorial of 3 equals to 3 into factorial of 3 minus 1, that is 2. Again, same function will call for finding factorial of 2 only. 3 into 2 into factorial of 2 minus 1, 1. Now again here you can see 3 into 2 into factorial of 1 means 1 into factorial of 1 minus 1 0. Next I'm taking here 3 into 2 into 1 into, okay. So factorial of 0 always 1. So that is what total result is, what's a 6 only here. So total result is 6. 3 into 2, 6, 6 into 1, 6 like this. But this is just formula based. But we need to write the code for this, how to find factorial of given number. This mechanism is recursion mechanism. A function that calls every time is called recursion. So factorial of 3 means 3 into factorial of 2, 3 into 2 into factorial of 1, 3 into 2 into 1 into factorial of 0, 3 into 2 into 1 into 1 like this. Let's see the implementation. But actually, if you want to find factorial of any number in Python logic, so no need to write any logic because there is a built-in function is there, factorial function. First, let me write the code. After that, I'll show you built-in function clearly. So I'm creating one function with the name factorial or any name also you can take, not a problem. Factorial of n. And I'm just pausing here. I'm not implementing right now. Let's print this factorial factorial of 3 is factorial of 3 is, so what I can say here, factorial of 3 is factorial of what, 3 only I'm passing. Okay, so the moment when we call this factorial of 3, then factorial of 3 n equal to n value 3, then pass it I'm doing. I'm using pass keyword here. So let's see this pass keyword, how I can remove this pass keyword and I can write the logic here. So when we go for factorial of 3, n value 3, so sometimes the n value will become 0 because factorial of 0. So that's the reason if n equal to 0, then result is always what, sir? Actually 1 only, sir. Result equals to what? 1. Else a block, then result equals to result equals to n into factorial of n minus 1. Then return result like this. Return result. So print factorial of 3 is factorial of 3. So df factorial of n, if n equal to 0, result equals to 1, else result equal to n into factorial of n minus 1, return result only here. So print factorial of 3 is what's actually factorial of 3. Let's see this. It will return the result value. So let's execute this. I'll keep the breakpoint and execute so that you will get. So result is obviously 6. Factorial of 3 is 6. So look at this. This type of function is called recursion function because every time this function is going to call itself only. Let's see this. I'm keeping breakpoint here. So let's debug 30, test 34. Now the moment when I start debugging now you can see function key plus F8 I'm hitting. Now you can see n value 3. 3 equal to 3 not correct. Look at this. 3 equal to 3 false. It's not correct. So now you can see result equals to n into factorial of n minus 1. N into factorial of n minus 1. So n value 3 only. N minus 1, how much it is? 2 only. Again factorial of 2 purpose, it has to call itself again here only. So this is recursion. It will go back. N value 2. 2 equal to 0 not correct. False. Again it will go to where, sir? Else block result. So factorial of 2 minus 1, factorial of 1 only. Again factorial of 1 purpose, it has to call again back n value 1. 1 equal to 0 not correct. False it is. False means it will go to else block. N minus 1, 1 minus 1 that is 0. That means what? F8 it will go. N value 0. Now you can see n value equal to 0 true. Then it will return what, sir? 1 only. Because factorial of 0 is 1. Then it will collect the return value result 1. Right now result is holding 1. It will go back 1 into 2, 2 into 3, 6. 6 values coming. But this is just a logic program for finding factorial of any number. But this is not required, I'm saying, in Python. So almost you have written 8 lines of code. This is not required. So why? Because in Python there is a built-in module. That module name is called math module. Let's see this. What is math module? How do we work with them? Test 35 is there here. Now you can see this. I'm trying to import math. Math is a mathematical module. It's a built-in module in Python. So using this module, what we can do? So a lot of mathematical functions directly we can use it. Directly we can use it. No need to implement it. Directly we can use it, this math module through here. So let's see this how to work with math module. Print math dot. So factorial I'm giving factorial of 3 here. So let's see this factorial of 3. Run this. So we are getting what actually? Just a moment. See here, math is a built-in module and math dot factorial of 3 here. So we got the result here. So did I write any logic here? No logic. Previously, just I have written this logic here. This is not required, I'm saying. But you have to know how to write the logic also. But here in Python, there is a built-in module that is called math module. This math module can offer lot of functions. Here, one of the function is factorial, and even not only factorial. So let's see this print math dot what actually square root of 4 I'm taking. So math dot sqrt4 square root of 4 is 2.0. Now next here you can see print math dot square function I'm taking, or power I'm taking here, power 3 comma 2. So now you can see 3 to the power of 2 9.0 it is there. Math dot power 3.3 comma 2 3 to the power of 2 9.0 here. Next here print math dot. So what I'm taking, floating point absolute. This is floating point absolute. Like so many functions are there, tangent, radians. Okay. So print math dot, so sine value, sine of 3 value, like this. Scientific application functions, mathematical functions we can apply directly by importing math module. But note this point, every time if you want to use this factorial function, square root function, power function, floating point absolute function, sine function, all these things, every time I mention module name dot function name like this. So you can avoid this module name dot function name directly. Also we can able to call factorial function, square root function, power function, all these functions we can apply. But only the thing is, so this is not the way import this math module. So what the way to import this math module means, from math import star. This is correct. So here star indicates what? All functions which are coming from math module. Suppose here I'm using only factorial. Look at this, factorial function only will work, remaining not work. So that's what I'm indicating. What star? Star means I want to access all functions from this math module. In that context, we can use what actually star. So let's run this. Now you can see run test 35 here. So now we can see 6, 2.0, 9.0, 34.3, 0.1411 like this only. Okay. So this is the case. So these are the mathematical module is there. This is one of the built-in module. How we use just now functools module. Same, it is a built-in module. Now it's time to discuss about modules in Python. So modules means what, and what type of modules are there? Can we create our own modules and making reusability of total program? Yes, possible. So let's see this module, how to work with module here. So modules in Python. modules in Python. In Python programming, every .py file acts as a module. Every .py file, .py file, .py file act as module. So look at this in my project. Left hand side, you are seeing there are so many files are there like test1, test2, test3. These are all modules only because every .py file act as what module only. So every .py file act as a module. So what is module? Module consists of variables and methods. Variables and methods. Suppose in one module, for example, here module contains a group of variables and group of methods. Each module contains each module contains group of variables and methods, or group of variables and methods. Each module contains group of variables and what's are methods clearly. Each module contains group of variables and methods. So in one file, in one Python file, you can declare variables A and B and so on like that. And we can declare methods also. Methods means like any number of methods you can include functions like that. Okay. Module contains group of variables and functions. Better to call functions. In object oriented, generally we can call it as that methods only. Right now, functions I'm calling. In one py file, we can include lot of variables and functions clearly here. Let's see this how we can able to create one module and how to work with that. Modules can be two types. One is predefined modules, or these also called as what's are actually built-in modules. Built-in modules. Next one is user-defined modules. User-defined modules or user-defined modules or customized modules also. We can prepare our own modules here. Predefined modules or built-in modules. User defined modules also possible, sir. User defined modules. We will focus first user defined modules and later we will discuss lot of predefined modules. Predefined modules means when we install Python software, automatically these modules will be available, sir. Just now we discuss for accessing reduce function, we use functools module, no, that is predefined. And for accessing factorial, square function, power function, what we use math module, no, that is predefined. It's a built-in module, directly will come. But user defined module means we can create our own module with a lot of stuff in that, means variables and methods we can include in that. So what is the module advantage, sir? Module is for reusability. Module is for what purpose? Reusability. So just now we finished the functions topic. Functions also reusability, no? Functions. Yes, functions also reusability purpose. Functions also providing reusability. But functions reusability is the scope is limit actually. Inside the function body, how many statements you include, only that statements we can able to reuse, but remaining we cannot able to reuse. Inside the function body, how many statements we include, that statements only we can able to reuse, remaining we cannot reuse. So that is exactly here reusability model. Reusability means entire the program, how many number of functions, how many number of variables we include, everything we can able to access outside the program. That is the module advantage. So module is for reusability purpose. Okay. Yes. So once we prepare a program with lot of variables, lot of functions, that all functions and variables we can able to reuse into other program in the sense outside the program. Suppose let's create one module with a name called sample.py. This module is having some variables and functions also. Suppose one variable is there, a value 10, and two functions are there like add function x comma y. This x comma y, I'm printing here just sum is x comma y, x plus y, sorry, x plus y. So this is one function, and this is also one more function. One more function I'm taking add function, not here I'm taking subtract function. Sub x minus y I'm taking x minus y. A value 10, add function I'm creating, subtract function I'm creating. These values are coming fine. So this sample.py is one of the module. This module contain one variable. Yeah, package is also there. I'm not going to disclose right now because that will come into advanced Python. Just why I'm not disclosing right now, just to avoid confusion. Okay. So actual hierarchy is this is only, sir. Packages, modules, classes, methods, variables. This is exact hierarchy. In advanced Python, I will cover this also. Why I'm not covering packages? Because classes I have not introduced so far. In object-oriented program only classes I can introduce. No, after that we will go for packages. Right now we are working with modules, modules with only methods and variables again, not classes even. When it comes to packages, I'll cover modules, classes, methods, variables, hierarchy. Package is a folder. Each folder contains group of modules. Each module contains group of classes. Each class contains group of methods. Each method contains group of variables. This is exactly hierarchy. You just leave it to me that I'll take care of this. Okay. Let me focus on modules right now. So this is my module sample.py. So it's this module is having one variable that is a, and two functions are there like add and subtract function, and these two functions are available here. But once I run this sample.py, you will not get any results, sir. Why? Because you declare the variable, but did I print this variable a? No. I defined the variable, I defined the methods add and subtraction. Did I print this methods? No. Did I call this method? No. So my intention is I need to prepare the module like sample.py. I need to access this variable. I need to print this two functions into outside the program. So how I can access means, first of all, this sample module contains members. What are the members here? A, add, sub are members of the module. A, add, and sub. These are what actually members of the module, members of the sample module, members of the sample module. If you want to access these members, then other program, like for example here test.py is there, for example test.py. In this program I want to access this module stuff. How I can use? In the sense, first of all, from which module data you are trying to access, that module name you can import as a header section on the top. After that, if you want to print this a which is coming from sample, so we have to print what's are here, print sample dot a, we have to use module name dot a. But you want to call this function add and subtract function which is coming from sample module, again directly we cannot call the function sample dot add function, that's passing two numbers, sample dot subtract function, and again passing two numbers like 20 and 10. I'm taking 20 or 5, I'm taking like this, sample dot subtract function. Okay, so import sample, print sample dot a, sample dot add, sample dot subtraction 20 comma 5, sample dot add 20 comma 10, like this only. This is perfect. Let's say practically. So first let me create one sample dot py file. This is I'm considering as a module name. So you can take any name, any py file is act as a module. I'm taking sample. This sample.py is having one variable. This variable just printing purpose only. I'm not reusing this variable name in any functions. There is no relation of that variable and this functions are. Print sum is x plus y. Then df subtract x comma y. Print subtract is x minus y. So look at this, whenever I try to run this sample.py, so this won't give any result because you declare a variable a value 10, but you have not print this a variable here. So we create a function like add and subtraction, but we have not called any functions here. No, did I call any functions here? No, add, subtract, no function I called. So where I want to use this add and subtraction and variable a value means I have to go for test.py. Let me go to test.py. Okay, test.py is having task code. Let me copy and paste here. Right. So in test.py, I want to access the values which is coming from sample.py. How to access? Directly can I go for print a? No, because a is not defined in this program test.py. Okay. So what I can do here, first import, import sample. So here I'm trying to do sample dot what actually a only. Import sample. So print sample dot a only here. Okay. So sample dot a means we are accessing a variable value from sample module. Here I declare I want to reuse that into test.py. Similarly, I'm calling the functions sample dot add, which is expecting two values. So I'm passing again sample dot subtraction, which is expecting values like 4 and 1. So this is module name. That means from this program, we are trying to access variable A, we are trying to access add and sub. So if you run test.py, so test.py file is reusing the stuff from sample.py. So this is exactly module purpose actually. So how to reuse it? Once we prepared your code in one programming logic, that program code, that program logic we can able to reuse into multiple other programs just by importing the program name on top of the program here import sample. So this is module advantage. This is module name. Sir, if you want to access members of the module, A is one of the member, add is one of the member, subtract is one of the member. To access members of the module, then is that compulsory required to give the module name dot member name like this? Yes. So we have one option. Module aliasing option is there. Just now we discussed function aliasing. No, same module aliasing concept is there. Module aliasing means every time no need to give sample dot a sample dot add like this. We can provide alias name sample as yes only. I can say that import sample as yes only. Sample as s means s is the alias name. Okay, so here s I'm using. So once we change the alias name of the module, you can't use module names or you can use only alias name. So that's what I'm using s. So let's run this. We got same result again. So this is called alias name of this sample module. Every time instead of using sample, you can use s only. It is a short form. Or else if you don't want to use this even alias name also, sometimes I need direct access or variables and methods I need to access here means, so I recommend directly from statement. What is the advantage of from statement means from sample import star. From statement advantage is no need to use any module name, no need to use any alias name. Directly we can able to access what's are here, this one only. From sample import star. Print a we are taking here. Now you can see. So now you can see run test. So we are getting, did I use any module name dot a module name dot add? No. So directly I'm accessing a add sub which is coming from sample. Star indicates all functions which is coming. Okay. Yes, obviously performance of that. Yes, it will load. That's what I will not recommend. No? So if we use star means it will load the what we can say all the functions which are available from sample, but you may use later only one variable, but it will all will be load. So that's what performance issues. So better to use what is required to use. You can use members also instead of star. A add sub like this only. SUB like this. So this is good practice. If I use only A, then we can use only A. This is the better option. Only A will be loaded from this sample module. So easily we can able to access clearly, sir. This is A. Fine. So this is about basic information related to module today. We will discuss more details about these modules in tomorrow session, how to work with multiple modules also. There is member aliasing also there. So once again, I'll explain this one and we will continue from here onwards tomorrow. That's all for now.
Thank you.